Complex numbers. Let's go right to an example. If x equals 2 minus 3i and 4 equals 4 plus 2i, what is the value of xy? Well, xy is going to be 2 minus 3i times 4 plus 2i. Use the distributive property, FOIL method, box method, whatever floats your boat. We're going to multiply 2 by each of those terms. 2 times 4 is 8, plus 2 times 2i is 4i. Going to multiply negative 3i times each of these terms. Negative 3i times 4 is negative 12i. Negative 3i times 2i is negative 6i squared. We're going to combine like terms. 4i minus 12i is negative 8i. And over here, I squared is negative 1. That's a fact that you need to know. Negative 6, subtract 6 times negative 1 is a plus 6. If we then combine the like terms of 8 and a plus 6, we get 14 minus 8i, which is answer E. Number 9, which of the following expressions is equivalent to 3 plus 2i over 4 minus i? Well, to do this problem, we are going to get rid of the imaginary number on the bottom. It's a common practice that you don't want imaginary numbers in your denominator, and if you look at all the answers, for the possible answers, they don't have imaginary numbers on the bottom. To fix this, we're going to multiply the top and the bottom of the fraction by the conjugate of the denominator. Conjugate means the same terms, only instead of whatever sign that you're given, in this case subtract, we do the opposite, which is plus. If the original problem had plus, then the conjugate would be to subtract. So we're going to use the FOIL or box method again. We're multiplying the numerators and the denominators. 3 times 4 is 12. 3 times I is 3i. 2i times 4 is 8i. 2i times I is a plus 2i squared. Our denominator, anytime you multiply two conjugates, you get 4 terms, and the two middle terms always cancel. So you always end up with the first term squared, 4 times 4 is 16, and the last term of the binomial squared, and then you're subtracting those always. I times I is I squared. And it's a subtract I times a plus I, so it would be a minus. Combine like terms, we have a 3i and an 8i in the numerator, so it's 11i. I squared is negative 1. Our denominator, I squared is negative 1. We simplify this a little bit more. 2 times negative 1 is a minus 2. 16 minus a negative 1 is like 16 plus 1. Combine the 12 and the minus 2 in the numerator. We get this bad boy, which is answer J. Moving on. Here are different facts about multiplying i's by themselves. There's a point to this, and one of the points is there's a pattern. I to the first, second, third, fourth, fifth, sixth. If you increase the exponent by 1 each time, the answer is going to be I, negative 1, negative I, 1. And it repeats. I, negative 1, negative I, 1. So the important thing for us is to determine how we can figure out this pattern if we have a really large exponent. Here's what we're going to do. We're going to take the exponent and we're going to divide by 4. Why by 4? Because there are 4 numbers in our pattern. 4 goes into 1 0 times, and there is a remainder of 1. If we look at 2 as an exponent and divide the exponent by 4, 4 goes into 2 0 times, remainder of 2. Notice the remainder is the same as the exponent. That's nice. The third one, exponent of 3, if we take 3 divided by 4, it goes 0 times. Get a remainder of 3. There's a point to this. Wait for it. If you look at I to the 4th, no space here, we divide that by 4, goes 1 time, no remainder. Well, that same pattern continues. For example, let's just pick this one, I to the 7th. If you divide 7 by 4, goes 1 time, remainder of 3. So what I'm proposing is every time you get a remainder of 3, the answer is going to be negative I. Every time you get a remainder of 1, if you divide the exponent, you're going to get I for the answer. If you divide the exponent by 4 and you get a remainder of 2, you're going to get negative 1. And if you get a remainder of 0, you're going to get 1. I'm not suggesting you memorize that. I'll just derive it each time. It doesn't take nearly as long as it did there. So there's a shortcut there. I kind of like what I just did better than the shortcut. If I squared is negative 1, what's the value of I to the 34th minus negative I to the 30th? So I would derive this next part every time. I would take I to the 1st. What does that equal? That obviously equals I. And I would take I to the 2nd. That's I times I. I times I is negative 1. And I would take I to the 3rd. That's going to be the previous answer times I, which is going to be negative I. And then I to the 4th, a negative I times I. That's going to give us 1. So if we're looking at what we're trying to figure out for this, I to the 34th, I'm going to take the exponent, I'm going to divide it by 4. 4 goes into this 8 times. 8 times 4 is 32. We got a remainder of 2. So that tells us that I to the 34th is going to equal negative 1. So let me write that down. I to the 34th equals negative 1. The next thing we got is negative I to the 30th. That's equivalent to I to the 30th, because if you multiply a negative number by itself an even number of times, the answer is always positive. Let's take the exponent and divide it by 4. Goes 7 times, remainder of 2. So that's also negative 1. We're supposed to find the value of I to the 34th minus negative 1, negative I to the 30th. We've just determined that I to the 34th is negative 1. We've just determined that negative I to the 30th is also negative 1. Subtracting a negative is like adding a positive, so you get negative 1 plus 1, which is 0. Answer D. At this point, you should be able to finish all the exercises in set 4.